Hello, everyone. Thanks a lot for coming. Today, we are here to discuss how you can develop, deploy, and debug applications using Google Cloud Platform's developer tools. I'm Nikhil Kaul. I'm the product marketing manager for developer tools at Google Cloud. And with me, I have Russell.
I'm Russell Wolf, and I'm the product manager for Cloud Sοurce Repositories.
So, as you might have seen in the previous slide, the way we structured this presentation is essentially into three parts. In the first and the foremost part, we specifically wanted to talk about developing applications. In the second part, we wanted to showcase how you can deploy those applications. And in the third part, we specifically wanted to deep dive into debugging an app. In the first part, when we talk about developing an application, we wanted to deep dive into how you can store your source code on Google Cloud Platform, the different integrations which are available to make developers productive as a part of storing that source code, and finally, the different features which are available to build security in. In the second part, which is essentially targeted at deploying, we wanted to showcase how you could use Cloud Sοurce Repositories specifically to build, test, and deploy an app. And finally, in the third phase of the presentation, we wanted to showcase how you can use Cloud Sοurce Repositories along with the different integrations with Stackdriver for debugging an applications. The one thing which you would see across these three different phases is we are leveraging Cloud Sοurce Repositories along with the different integrations it provides. So just to level set and ensure everyone in the audience understands what Cloud Sοurce Repositories is, we go to the next slide.
Cloud Sοurce Repositories is a generally available service on GCP that allows you to host private Git repositories. Because those repositories are hosted on GCP, it makes it really easy to integrate with other GCP services, such as Stackdriver Debugger, Cloud Build, and Cloud PubSub. There are three areas where Cloud Sοurce Repositories really excels. First is with its high scalability. Google has invested in a highly scalable Git infrastructure for many years to support the needs of two of the largest Git projects that exist, Chromium and Android. Cloud Sοurce Repositories uses that same highly scalable Git infrastructure, which means that you can host large files, large folders, large repositories, and do it all for many users with very low latency. Next, Cloud Sοurce Repositories has high reliability because all repositories are hosted in multiple data centers across different regions. In theory, even if half of the world's network was disconnected, all repositories would still be able to be served. We even isolate data centers and perform periodic disaster recovery tests just to be sure your source code is safe. And finally, to help meet your organization's compliance needs, Cloud Sοurce Repositories doesn't just integrate with identity and access management, meaning that you get to use the same identity you use for the rest of your organization, and use a consistent permission model you use with the rest of your cloud resources. It also features audit logging, which means that if something were to go wrong, such as code exfiltration, you can be sure that you can do an investigation and figure out what happened, who did it, and when it happened. Cloud Sοurce Repositories also does daily, globally redundant backups, which means that if some disaster were to occur, your source code is safe. And finally, with automatic encryption in transit with per repository encryption keys, your IP is protected.
So remember the three pieces of the presentation: develop, deploy, and debug. So let's start with the first phase of how Cloud Sọurce Repositories can actually help you develop applications.
There are two ways to connect your source code to GCP. First, you can do it by mirroring your code from an external Git provider, such as GitHub or Bitbucket. You only need to set up that mirror once, and all of your source code is copied over. After that, anytime you make a new commit to GitHub or Bitbucket, that commit is then copied over to Cloud Sοurce Repositories as well. Now, you may be asking the question, what benefits do I get from copying my source code over to GCP? Well, first, you can take advantage of code search. We'll dive into that a bit later, but I can just tell you that Googlers rely on it every day, and I bet you'll find it great too. Second, you can take advantage of a bunch of other integrations that Cloud Sοurce Repositories has with other GCP services. For example, Cloud Pub Sub, Cloud Build, and Stackdriver Debugger. And we'll also demo all of those later. Alternatively, you can choose to host your source code directly on Google Cloud Platform in Cloud Sοurce Repositories and have your entire development team collaborate there. Next. We're also excited to announce an upcoming integration with GitLab, which means that you'll be able to host your repositories on GitLab and mirror all that source code into Cloud Sοurce Repositories to take advantage of all of those integrations. This will be available in the next month.
The other goal of us providing Cloud Sοurce Repositories is making developers more productive. And traditionally, what we see is developers spend a lot of time trying to find answers each and every day. Answers to questions like how a function should be called, what does the class look like, where does the class get instantiated, why is something failing, or who changed the code resulting into the code base failing. And answers to those questions can be easily found through code search functionality of Cloud Sοurce Repositories.
Code search allows you to search across your entire repository with a single query. This is especially useful when you don't have all of your organization's repositories cloned down from the server to your local machine, or all of your local repos aren't up to date with the server. Indexing is super fast, so even if you're in a large organization with commits constantly coming in, you're always searching against up-to-date code. In fact, Cloud Sοurce Repositories uses the same document indexing and retrieval mechanisms used by Google Search, which means that it can handle your searches quickly and across very large corpuses of code. There are three areas where code search for Cloud Sοurce Repositories really excels. First, with support for regular expression search. That means you can craft queries to answer even the most complex of questions. Second, by having a syntax-aware index. That means that you're not just searching for text. You can also search for specific entity types, such as a class or a function. And finally, with result suggestions as you type, you can get answers to the questions you're looking for right away without having to wade through any search result pages. Cloud Sοurce Repositories also helps you keep your code secure. It's generally not a good idea to check service account credentials or security keys into a version control system. However, sometimes you may accidentally do that. And that's where Cloud Sοurce Repositories is there to help. With the push block feature enabled, if you try to push a commit to the server that contains a GCP service account credential or a security key, that push will be blocked, and you'll be given information telling you what file was in violation and why it was blocked. If your commit was just fine, it makes it to the server. Let's go ahead and take a look at a demo for this all. We're first going to start by showing how you sync a repository from GitHub. Then we'll take a look at the source browser in Cloud Sοurce Repositories and look at the contents of that repository. After that, we'll do a global code search. And finally, we'll take a look and see how push block works in action. This is the homepage of Cloud Sοurce Repositories. Here you can see your favorites and your recently viewed. And these will contain repositories, branches, folders, and files. It helps you quickly jump back into the context of whatever you were last working on. We can go up to the top right and select Add Repository to add a new repository. And here we can choose between connecting an external repository or creating a new repository. We're going to choose to connect an external repository. We're going to add it to this cloud project I created specifically for Next, and we'll choose the GitHub provider. I'm going to authenticate GCP to connect to GitHub, and I've already signed in with my GitHub account on this computer, so I'm already in here. And I'm going to choose to connect this Cloud Debugger Python repository that I have access to on GitHub. I just click Connect Selected Repository, and now Cloud Sοurce Repositories is setting up a webhook on that GitHub repository. That way, whenever changes happen to that repo, we can then mirror the changes back over. And it's also doing a one-time full clone of that repository, including all the branches and tags and everything else. It looks like that repo has been cloned over. So let's take a look. Here we can see the layout of the repository. In this branch picker at the top, we can see that it's copied over all the branches, tags, and commits. We can also see the README file for the repository rendered here, and click into Change History to see the history of all of the commits that have happened in this repository. As we navigate through the source browser, navigating through folders, and even down to files, we can see that the change history updates for that scope. Once you're looking at a file, you can click Blame to see which user was responsible for the changes on each line of code and see the associated commit and message that goes along with it. You can also go to Change History and select a diff between any two versions of a file. And you can click on a commit ID to view all of the changes that took place in that commit. Finally, you can compare those commits to other commits in your repository and see the difference of all of the commits that happened in between, as well as all the changes to the files. Let's go ahead and take a look at the code search functionality now. I'm going to change from searching in this repository to searching across everything I have access to. And as you can see, as I type individual characters, I'm getting these result suggestions as I type. And they're showing that it's finding variables, functions, structs, and more. I can go ahead and click on one of these suggestions, and I'm taken directly to the line of code where that function exists. I can also go to the search box and just submit this query and view all of the results across all of the repositories I have access to. You can go in and preview all the matches in the file to see if it's what you're looking for, and continue iterating through these different previews until you find the exact match that you were trying to get to. This really helps your developers be productive and solve those tasks that Nikhil was talking about earlier quickly. Now let's take a look at how push block works. I'm going to switch over to Cloud Shell. Cloud Shell is another GCP service that allows you to use a command line to manage all of your GCP resources, as well as a code editor. And all of this is hosted in a VM just for you, so you can access it from the browser anytime you want. So here I'm inside of this Cloud Functions repository. And earlier today, I was actually testing out deploying my Cloud Function from a third-party service to build a nice integration. And because I was doing that, I downloaded some GCP service account credentials to my machine. Those are contained in this key.json file. Now, later in the day, I may go and make an innocuous change, such as fixing this typo from this repository to this repository. And I'll track it with Git, make a quick commit saying fixing typo, and push it to the server. Now, you see I made a mistake there. I was going quick. I just did a git add dot that added everything in the repository that wasn't being tracked to be tracked. And here we can see that my push was rejected. Pushblock has said that the push has been rejected because we detect that it contains a private key. Please check the following commands and confirm it's intentional. I can go ahead and execute this git show command, and it will show the contents of the private key, which I'm not going to do on stage. And if I detect there was actually something in there that wasn't a private key and this was a false detection, I can go ahead and just run git push and override to say I don't want a key check. And with that, we've seen how Push block and Cloud Source Repositories can help you from making those critical mistakes that can really put your organization's security at risk. And with that, let's go ahead and switch back to the slides, and Nikhil can talk to us about the next part of our presentation, which is deploying.
So with that, we finished the first part of the presentation, which was essentially developing an app. When it comes to deploying an app, many of us are deploying to different environments. These could be VMs. These could be containers. These could be serverless environments. Or these could be mobile platforms. Irrespective of whether you're using Google Compute Engine VMs, Google Kubernetes Engine for deploying containers, serverless frameworks such as App Engine or Functions, or mobile platforms like Firebase, Cloud Source Repositories integration with Cloud Build can come in really handy here. Cloud Build is Google's continuous integration, continuous delivery platform. And Cloud Source Repositories integrates with it. In fact, as you would see within the demo, the good part about the integration is that there are no CI servers to set up, manage, or maintain. As you would see, within few clicks, you will be able to achieve automation from source to production. And the good thing is you can deploy your app to different environments. In fact, if you're someone who likes to manage their build configuration as code, you can use cloudbuild.yaml specifically for specifying build steps. You can specify the steps you want to perform as a part of build. You can specify the steps you want to perform as a part of test. And you can specify the steps you want to perform as a part of deploy as well. The workflow looks something like this. As a developer, I write the code, and I check it in Cloud Source Repositories. From there on, Cloud Build takes over. And Cloud Build takes over primarily because we have set up a trigger to notify Cloud Build that a code with a change has been checked in. Next, as Cloud Build takes over, Cloud Build can build both Docker artifacts as well as non-container specific artifacts. Example of these could be Gradle, Maven, Go, Bazel, etc., etc. Once the artifacts have been created, Cloud Build can run different types of tests, whether these are unit tests or integration tests. If you're working with containers specifically, in the artifact management space, which is the fourth point over there, Cloud Build can help you scan those artifacts for vulnerabilities as well. We'll talk more about it in the later parts of the presentation. And finally, if everything looks great, you can deploy that app to different environments in the deployment phase. However, when you're working in a continuous integration and continuous delivery environment, you need notifications as a part of that process. You might want notifications during the start as well as the end. And that's where the notification piece comes in handy.
Both Cloud Source Repositories and Cloud Build offer integrations with Cloud PubSub. That means that when a new commit is checked into your repository, a new build is kicked off, or a build completes, you can generate a PubSub event to a PubSub topic. You can then have a Cloud function configured to monitor that PubSub topic, watching out for these new events coming in. And when a new event comes in and a Cloud function triggers, you can have it invoke a third-party service, such as Slack, email, or any other that you want to work with. Before we go on to look at a demo with this all, I'm going to ask Nikhil to go ahead and walk us through the workflow of what we'll be doing in the demo.
Sure. So we've set up a really simple demo to demonstrate a continuous integration and continuous delivery pipeline. That's the first phase of the demo. And the second phase of the demo is essentially targeted at getting a notification to Slack. Let's break down these two phases and go into more detail one by one. Both of these two phases essentially start at the same place, which is developer writing a code and checking it into Cloud Source Repositories. In the first phase, what happens is, as developer writes a code and checks it into Cloud Source Repositories, a build gets triggered because Cloud Build gets a notification through the build trigger which we have set. Once the build gets triggered, Cloud Build essentially deploys the app to the test version of App Engine and runs end-to-end tests. If the tests pass, Cloud Build then deploys the app to the production version of App Engine. That completes the first phase of the continuous integration and continuous delivery process. In the second stage, what we are doing is we are sending a notification to Slack. The steps look something like this. Starts again with developer checking in the code. Cloud Source Repositories publishes an event to Cloud's Pubs Hub. Cloud Function then subscribes to the Pubs Hub event, and since it's subscribing to the Pubs Hub event, it posts the message which it received in the event to the Slack. Let's see both of these demos in action. Russell.
Let's switch over to the demos. Here we can see an application already deployed to production. It's a very simple app. Basically, it's a guest book. You can write a message in this box here, such as, welcome to Next 2019, sign in the guest book, and it's posted there along with the user who wrote it. You can switch over to other guest books as well, and they'll have a distinct set of messages too, and you can log in and log out of this application. Now, the title App Engine Guest Book maybe isn't the most suitable one, so let's go ahead and change it to Next 2019 Guest Book. Just something easy for us to do here, and we'll change it first by going to Cloud Source Repositories, and I have no idea actually where this code is declared. But it's a simple code change, so I can do it. So I'm going to search for App Engine Guest Book, and it found the result in one of these repos. And I see it's here, so I can just click Edit Code. And this is now going to launch me an instance of Cloud Shell. It's going to make sure that this repository is mirrored into this VM, and I'll have this complete workspace in the cloud. Here, I already have it mirrored over, actually, so it's just asking me to change directory. And I'm at that line of code, so I'm going to change it from App Engine to Next 2019. We'll add this to Git. We'll Git status to make sure I'm not checking in any security keys or anything like that. Git commit, changing title. And then finally, I'll push it to the server. Now, as this commit gets pushed to the server, just like Nikhil mentioned, we're kicking off a build. So let's switch over to Cloud Build now. And we can refresh and see that a new build has been invoked. Clicking into there, we can see that it has 3 distinct build steps. We'll dig into those into detail in 1 minute. Here you can also see that we have real-time logs that are being produced from this build, so we can see what's going on. Let's go ahead and take a look at this build trigger that we talked about. So when code made it to Cloud Source Repositories, it kicked off this build and told it what to do. First, we notice that there's a trigger type. The trigger type allows you to specify when you want this trigger to activate. You have the options between a branch or a tag. And here I've chosen branch, and I can choose a regex that I want to match for when I want that build to be invoked. In this case, I'm doing a .star because I only have 1 branch, and I just want to trigger off that. But I could also specify an exact branch name or a regex for a set of branches I want to kick off builds for. I can also choose to filter those builds by changed files. And so here I could use a regex to say, I only want to trigger builds if there are changes in my source folder. Or I don't want to trigger builds if it's just a change to a config file or a markdown file. Once you've decided when you're going to invoke a build, you then get to decide what you want to do when a build is invoked. You do that inside of build configuration by choosing between using a Docker file or a cloud build configuration file. In this case, we've used a cloud build configuration file, cloud.yaml. Let's take a look at this cloud.yaml. We can jump back to Cloud Source Repositories. I could search for it, but it's right here. And so here we can see the first step that's declared in the cloud.yaml. This step says we're going to deploy the current code to a test version on App Engine without promoting it. I'm just declaring to use this existing image stored in container registry for gcloud. I'm saying to perform the app deploy commands and specifying the app.yaml for App Engine and an index.yaml for the backing data store. And then I'm specifying these two parameters, version test, so I'm naming that version, and I'm saying not to promote it to production. After that, if and only if that step completes, I proceed to the next step, which runs end-to-end tests against the test version on App Engine. So here, I'm just using another image that's already stored on container registry, which is an Ubuntu image. I'm opening into Bash, installing some prerequisites, and then executing this runtests.bash script. Here we can see I'm just declaring the URL for my test environment on App Engine, and I'm executing the end-to-end tests. If those tests all succeed, I proceed to the next step, which deploys the current code to a new version on App Engine that's promoted to serve production. Again, I just use that gcloud image and call that same app deploy, but this time I'm not naming it to a test version, and I am letting it promote to production. That's really all there is for setting up this automated test environment, running my end-to-end tests, as well as promoting to production if those succeed. I recognize many of you might not use App Engine. There are many other deployment runtimes. If you were to deploy to Kubernetes, there's cloud build steps for that. If you wanted to deploy to Cloud Functions, it's as simple as specifying your function name. And finally, there's even steps if you're trying to go to mobile and you want to deploy to Firebase. Now that we've seen how the cloud build YAML does that final part of showing what we should build, let's return to the build and see what's happened. Here we can go back to build history, and it looks like the build succeeded. We can see that that first step of deploying to App Engine in this test environment and not promoting it took 17 seconds. Spinning up that Ubuntu image, installing a bunch of these prerequisites, and then running our end-to-end integration tests took another 54 seconds, but they did pass, so that's good. And finally, deploying to production and promoting took another 30 seconds. Let's go ahead and check out our application on production. We can refresh this page, and we see that it's now updated to Next 2019 Guestbook. Now that we've seen how that CI/CD automated workflow works, let's take a look at that other part of the demo that Nikhil talked about, which is posting the messages to Slack automatically to inform your team. So here I have a Cloud function already created called CSR to Slack. It's watching this pub sub topic I've called CSR, and I've told Cloud Sοurce Repositories to post pub sub events to that CSR topic whenever something happens, like a new commit coming in. I'm then pulling source code for this Cloud function from a different Cloud Sοurce repository and executing this message Slack function. Here we can again go to Cloud Sοurce Repositories and take a look at what that looks like. Finds it right away for me. And we can see that in this function, I'm going to be messaging the Next 2019 channel saying that user's email just pushed a new commit to this repository. So let's go over to Slack, and we can see that it indeed did post that message to that channel. Whether you're trying to interact with Slack or any other third-party service, integrations with Cloud PubSub and Cloud Functions make it really easy. Now that we've looked at this demo, I'm going to let Nikhil tell us a little bit more about some of the deploy technologies that we have that are specific to containers. So let's go ahead and switch back to the slides now.
So far what Russell showed in the presentation was really catered towards App Engine, but many of you in the audience might be using containers on a day-to-day basis to deploy applications. If you're working with containers, as a part of Cloud Build, we have something called as vulnerability scanning. Vulnerability scanning allows you to identify security vulnerabilities early on in the software development process. Package vulnerabilities for Ubuntu, Debian are identified right as soon as the containers are built. It also provides you detailed insight by providing details such as the severity level of the vulnerability, what is a CVSS score, and whether a fix is available. In fact, if you want to take this process to the next level and further automate your tool chain, you can use vulnerability scanning with binary authorization, which will be going GA soon. Binary authorization essentially lets you define policies based upon your organization needs. For instance, as an organization, you can decide and define that we get to deploy only those containers which are actually tested. What this means is, if some developer actually ends up deploying a container which was not tested as a part of CI/CD toolchain, that container will not get deployed. The image above here is essentially doing something else, however. What we are doing over here is, developer checks a code into Cloud Source Repository, Cloud Build creates a build, the container gets scanned by vulnerability scanning, and then essentially binary authorization checks for a signature on the image from vulnerability scanning. If a signature is found, the container is deployed to Google Kubernetes Engine, and if a signature is not found, audit log is provided on why the specific steps were not performed. With that, we have essentially completed 2/3 of the presentation. We specifically looked at developing an app. We specifically also looked at deploying an app by showcasing the Cloud Build integration with Cloud Source Repositories. However, as a developer, many a times, we also face challenges where we have to debug an app, especially in production, and we're not able to replicate those issues on a local environment. And that's where Cloud Source Repositories integration with Stackdriver really comes in handy. There are essentially 2 ways which we allow you to debug your app in production. The first and the foremost way is Stackdriver's debug snapshots. This comes in really handy when you're actually debugging an app in production. Let's take the following example as an instance. You're trying to debug an app in production, but that issue is being faced only by one specific user. And as a result of which, identifying that issue on your local environment becomes really difficult. And this is where Stackdriver's debug snapshot provides you details. It captures the entire call stacks. It inspects the local variables. In fact, to do this, you do not even have to slow down or stop your app. And the best part is, once you select the lines on which you have to set up these debug snapshots, all your running instances of the app can start automatically capturing these debug snapshots. The other way of debugging with Stackdriver is log points.
As Nikhil said, Stackdriver Debugger also lets you set debug log points. Debug log points allow you to set a custom log message on a particular line of code. That custom log message can then reference the current application state, as well as only log under certain conditions. For example, you may want to log the value of a variable only if the value of that variable is outside of an expected range. I like to think of it kind of like printf debugging, except you don't need a single printf in your code. And since you're using Stackdriver Debugger in production, it's important that you don't even need to restart or stop your application. Finally, Stackdriver Debugger also integrates with Stackdriver Logging, which means that you can store, search, analyze, and alert on these debug events. Let's go ahead and take a look at debug snapshots and debug log points in a demo again. Can we switch over to the demo, please? Here we can see the Stackdriver Debugger user interface. At the top, we have a service selector. This allows us to choose between the various services and versions of those services that we have deployed. I'm going to go ahead and switch over to the one that we've now promoted to 100% and is backed by the Cloud Source repository at the commit we just made. Stackdriver Debugger automatically pulls in that source code and allows me to navigate through the entire file tree. We're looking at guestbook.py now, which is where the bulk of the logic for this application exists. Now, when a user goes in and posts a message to the application, that happens within this function down here called post. Now, I'm sure you've all been in situations where you've had a user running up against your production service. They're running into a problem. You try reproing it locally. It doesn't repro. You try reproing it on your production service as well, and you just can't repro it. Stackdriver Debugger can come in to help a lot with those types of situations. Here, I can go ahead and go into my snapshot panel and set a condition saying user email equals Cloud Sοurce Repositories 2019, which is the name of the email I'm currently logged in with, at gmail.com. And let's go ahead and set this snapshot on the greeting.put, which is where we're going to insert the greeting someone signs in a guest book into our data store. And now we have a snapshot waiting there. You know, it may be in the next 5 minutes, it could be in the next day, but when a user comes in with that email address, it's going to capture the exact application state that that user was looking at. So we can find out what was happening for them. We can also set debug log points. And so in the meantime, while we're waiting for that user, I kind of want to see what's happening for other users. So I can go in and click on that same line. And for now, I'm just going to say if true. So I'm always going to have this debug log point happen every time someone posts a message. And I'm just going to say email and log the user email. I can then choose to add that debug log point as informational, as a warning, or as an error. And as I said earlier, all of that integrates back with all of your other logs in Stackdriver Login. So I'm going to add that log point. And now we just wait for something to happen. So let's go over to the application and make something happen. So I'm going to assign the guest book again, saying thank you all for coming to our talk. And the guest book is signed, and we can return to Cloud Debugger. Here we can return to the snapshot, and we can see that the snapshot was captured. This user posted in the default guest book, and that looks right. That's one I currently have selected. And it matched the user email that I was specifically looking for. I can then dig into the other local variables, such as inside greeting. I can see the value of the message that was written, such as thank you all for coming to the talk, as well as seeing the entire call stack of the application at that point to see if maybe something was executed that I didn't expect to be executed. I can also go in and look at our logs. And by refreshing the logs, I can see that indeed this log point was hit, and we now have a log in our logging system saying this user visited, and we'd get that if any other user visited as well. So I hope you all enjoyed seeing Stackdriver Debugger. It's actually one of my favorite tools we have on GCP, and I highly suggest you give it a try. I'm going to hand it back to Nikhil now to wrap things up and explain the main takeaways from our talk.
Thanks,
Can you please switch back to the slides?
So today we saw 3 specific things. We spoke about developing an applications using Cloud Sοurce Repositories. During that stage, we specifically saw mirroring source code from GitHub and Bitbucket to Cloud Sοurce Repositories. We spoke about how GitLab integration is coming soon. As a part of that process, we also spoke about code search and how code search lets you search across all the repositories you have access to. We showcased push block functionality, which ensures that security keys are not stored within source control management systems. That completed the first part. During the second piece, we specifically spoke about Cloud Sοurce Repositories integration with Cloud Build, which lets you automate your build, test, and deployment process of your pipeline. In case you're working with containers, we spoke about how you can leverage container registry vulnerability scanning along with binary authorization to set up specific policies. And finally, in the third part of the presentation, we spoke about how you can use Stackdriver to debug applications in production. With that, thank you so much for coming. We are still over here for any questions, and we would really appreciate if you could provide your feedback in the next app. We hope to see you again. Thanks a lot.